Hey, let's start chapter 5. It is called Quadratic Functions. 5.1 is graphing quadratic functions. This should be a little bit of review from Algebra 1, but we're going to learn some new forms, and you are going to have to know all the forms, so take special care to write them down. So first of all, what does the graph of a quadratic function look like? Because so far we've only graphed lines. So the graph of a quadratic function is a parabola. And this y equals ax squared plus bx plus c is the standard form for quadratic. When you graph it, you get these U-shapes that are called parabolas. Every parabola has a turning point called the vertex. And you also have an axis of symmetry, which is going to be a center line. It's a vertical line through the very center of your parabola, and the parabola is symmetric about that line. So if you fold the parabola in half, both sides would line up. So some things that we can tell from standard form. So if an equation is in standard form, the parabola is going to have these characteristics. If a is greater than 0, meaning if a is positive, your parabola is going to open up. If a is less than 0 or a is negative, it's going to open down. And these would be something you probably want to write down. If the absolute value of a is less than 1, meaning it's between 0 and 1, your parabola is going to be wider than the parent graph, and we call this y equals x squared the parent graph. If the absolute value of a is greater than 1, your parabola will be narrower than the parent graph. And so the parent graph, and we'll get into specifics on how to graph, but your parent graph goes through these points right here. So there's the parent graph. So when we're talking wider than the parent graph, you're talking about something that comes out like this. And then narrower than the parent graph would be something like this. Okay. So we have a vertex. So here's our vertex. The x-coordinate has this form to it. And so that is actually called our axis of symmetry. Right here you have x equals negative b over 2a. So that is going to be very important too, because that finds the x of our vertex. So all of this stuff, very important when we're going to graph. And so that's our first goal here, is to learn how to graph these. So I want to graph this. And the deal is, at the moment, you're going to graph with a table, because you don't know anything else about this. But if you start with your table and you just randomly pick an x, it might take you 4, 5, 6 points before you even find where your turning point is. And you have to have that turning point to completely graph a parabola. So you really want to start with the x of your vertex. And so I'm going to start with my negative b over 2a. And notice this is in the form ax squared plus bx plus c. So negative b, well, b is a negative 1. My coefficient on my x, over 2 times a, which is a half. I get a positive 1 over 1, which is just 1. So my x I want to start with is 1. And then what you're going to do is you're going to plug x in for these x's, and you're going to find y that corresponds to that x. So y equals 1/2 times 1 squared minus 1 minus 6. So a half minus 1 is negative a half, minus 6 would be negative 6.5. So that's my vertex, and you need to have that plotted. So you're at 1, negative 6, so that's counting by twos. Let me back up a little bit. 1, negative 6.5. Okay, so my rule for parabolas is 5 points. So you need to have the vertex and 2 points on either side. So 0, negative 1 would be good on the left, and then 2, 3 would be good on the right. And you don't necessarily have to write them out, but what you're doing is you are plugging them into your equation. Right, minus 0, minus 6. That's going to be negative 6. So at 0 we're at negative 6. And then at negative 1, let's see here, negative 1 squared minus a negative 1. Make sure that you square first before you multiply, so it's a positive 1 times a half is a half, plus 1 is 1.5, minus 6 is negative 4.5. So I'm at negative 1, negative 4.5. And then I'm going to go to the other side and put in 2. So I'm putting it in for both x's. So 2 squared is 4. Half of 4 is 2 minus 6 is negative 6. Yes, they should be symmetric. My only warning I would tell you is if you mess up on the left-hand side, let's say you messed up on 0, I wouldn't automatically assume that 2 is the same thing, because if you messed up on one of them, then they're both going to be wrong. Alright, so half of 9 is 4.5. Minus 3 minus 6 is negative 4.5. So at 3, we're at negative 4.5. When you draw in your parabola, they are functions, so they continue to go out. They never go straight up, and you need to have arrows on the ends. Okay, so that was from standard form. You're just going to use a table. But we have two other forms that you're going to need to have memorized, all three of them, that will help us a little more. The first one is vertex form, and if you remember, this looks a lot like the form we use to graph absolute values. It has an h and a k in it. So y equals a times the quantity x minus h squared plus k. In vertex form, hk is your vertex, and remember this minus sign comes with it, so you got to look at your sign there. The axis of symmetry then, because if that hk is my vertex and that x is that vertical line, my axis of symmetry is x equals h. In the other form, vertex form, this would also be called a factored form. Y equals a times x minus p times x minus q. So your x-intercepts are p and q, and because a parabola is symmetric, your vertex is going to be halfway between those, or your axis of symmetry is going to be halfway between those. And just like previously, a is going to tell you if it opens up or down. So that's always true for a. And in fact, that's true for any function for a. So this is in vertex form. So this is y equals a times x minus h squared plus k, in which case h is negative 5 and k is 2, and so that's my vertex. So I know that the point negative 5, 2 is on my parabola. And because a is negative, I know this parabola opens down. So before I even start, I know some specifics about my parabola. So when you start your table, you already know that that is one of your points. I want 2 points on either side, so I'm going to do negative 6 and negative 7, and negative 4 and negative 3. And I'm plugging them in. Let's see here. Y equals negative times negative 6 plus 5 squared plus 2. That is negative 1 squared is a positive 1 plus 2 is 3. Oh, hold on. Not 3. I forgot the negative in front. Okay. If we do this negative in front here, you're going to get 1, but then it's going to be a negative 1. Negative 1 plus 2 is 1. Which makes more sense because it does have to open down. So then we're going to put in a negative 7. So that's going to be negative 2 squared is a positive 4, but then it becomes a negative 4. Negative 4 plus 2 is a negative 2. So at 7 it's a negative 2. And then on to 4. So that's going to be a positive 1 squared, which is 1, but then it turns into a negative 1. Negative 1 plus 2 is 1. And then when we do a -3, you're going to get 2 squared is 4, but it's a -4 plus 2 is -2. So just, you're graphing still using a table, but because it's in vertex form, it already tells you where to start, and you didn't have to use your, let me get it right here, you didn't have to use your x equals -b over 2a, which you can use if you don't know where to start. So this one is actually in intercept form. So this is y equals a times x minus p times x minus q. And so then p is 3, not -3, and q is -1. So those are your intercepts. 3 and -1 are your intercepts. So then where's my line of symmetry? My line of symmetry should be here at 1, because that would be halfway between. So if I do my table and I start at 1, let's see here, so we're going to have 1 minus 3 times 1 plus 1, which is a -2 times a +2, which is -4, times 2, which is -8. And that works because it's supposed to be opening up because a is positive. And so in this one, I'll let you only have those 3 points. That's easy enough there, if you can get it where it's supposed to be. That you just have your vertex and your 2 intercepts. And later on we'll talk about it's those intercepts that we were really looking for. Okay, one more example. So this one we want to write these in standard form. So if you notice, the first one is coming to us in intercept form, and I want to write it in standard form, which is y equals ax squared plus bx plus c, if you've already forgotten. So to do that, I would probably first FOIL. So you're looking at 1/2 times x squared minus 4x minus 6x plus 24. If you remember how to FOIL, first, outer, inner, last, which is going to be 1/2 times x squared minus 10x plus 24. And then you want to distribute, and you want to keep the y equals there because this is an equation. 1/2 x squared minus 5x plus 12. So there's standard form. So for the other one, a binomial squared means you are going to FOIL. So this is really x minus 7 times x minus 7. And if you remember, it's a square of a difference if you remember the pattern for it. But we can just FOIL. It's x squared minus 7x plus 49 plus 2. I'm going to go ahead and simplify before I distribute. So distributing the -4, you're going to get -4x squared plus 56x minus 196 plus 2. So then y equals -4x squared plus 56x minus 194. Alright, there you go. If you have questions, please remember you can post them on the blog and we can start talking about them before you come back to class. So have a great night.